So, so, hello and welcome everyone to today's LeetCode challenge. This is our day 304, and today's LeetCode challenge is remove all occurrences of a substring from a given string. This is question number 1910. Remove all occurrences of a substring from a given string. We have given two strings, s and another string that is part, and we have to perform the following operations until all occurrences of part in the given S string can be removed. Find the leftmost occurrence of the substring part and remove it from S. That means we have to find any occurrences of that part in this given string, and we have to remove that. After removing all the occurrences of part from S, we have to return our new S, and this also states that a substring is a contiguous sequence of characters in a string. Let us take the examples. Example number 1 states that we have given input s that is equals to daa bc baa bc bc, and the part string is abc. So we have to remove the leftmost occurrences of this part as a substring in this given s. So let us took this d, and we have find that this abc occurs in this, so we have to delete these three characters from this given s, and after deleting these three characters the input s is updated to d a b a b c and bc, and again we have to check if this updated s contains any substring as part, and we found out that this updated s also contains a b c, so we have to delete this as well. And after deleting this occurrence of a b c in this s, the updated s is now d a b a b c. Again we have to check is there any occurrence of this part is in this s is or not, and we find out that this updated s also contains this ABC, so we have to remove this as well. After removing this, the updated S is now DAB, and after that we found out that then there is no occurrence of this part in this S, so we have to return this DAB as our final answer. Similarly, in example number 2, we find that we repeatedly deleted all the occurrences of part from this, and this the constraints for this question is pretty small. One is less than s dot length. S dot length is basically from 1 till 1000. So we can basically do our big O of n solution to this. A big O of n square solution to this is also accepted because constraints are very low. So what could be the basic approach to solve this? One of the basic approach to solve this is we can repeatedly do an operation to find that if this given S contains any substring that is equal to this part, and after that when we found out that is there if there any substring in S that is equal to part, so we have to erase that substring from the given string. So how can we do that? We will run a while loop that will check if this part is in this s or not. If that while loop is true, that means this will contain a substring that is equals to this part, and also with that condition we also take care of the condition that s dot length is always have to greater than equals to 0, because if s is empty, we cannot check our part in this. And if these two conditions gets true, then we can, inside that loop we can update our s from, let us first find out the starting index of this part in this. So let us assume that this is the given input, and inside the while loop we were finding the first index of part in this. So the first index of part in this is this. So we will now update our s from before and after the substring. After deleting this means we will concatenate the substring from 0 to till this index, and from this to the last index. And basically doing that will remove our part from this, and these remaining strings will concatenate, and our updated s will become this. Doing this repeatedly will remove the all occurrences in this s, and finally when this while loop gets false, our updated string is our answer, so we have to return our updated string. So doing this approach will takes you a time complexity of big of n square, because in while loop we were finding the index, or we will checking that is there any occurrence of this part in s or not. And inside that while loop we were also uh, checking for the substrings of this, and finding this occurrence, or finding the first index of this occurrence of part in s. So this will basically achieve a time complexity of big of n square. And how what could be the other way to solve this? So the other way to solve this is to use a stack. And let us try run our stack code. What could be the approach for that? This is a stack code which is written previously by me. First we have to first we will declare our stack, a stack that stores characters, and we will save our s.length into a variable n, and also the part length, what is the length of this given string part. And after saving all these, we will do some functions in it. So what could be the basic approach to solve this using stacks? The basic idea to solve this, let us made a basic approach to this. Let us took the example this first, and the part string is that. So we have to return basically the after removing all occurrences of this repeatedly from our s. So we can assume that we made a stack, and then we will start our loop from I equals to 0 and goes till its length. And doing that, we will first push our characters into a stack, and then we can check if our stack top is the stack top that contains the character, the topmost character is whether it is equal to its last character or not. If it is equal to its last character, that means it may be possible that the stack will contain any occurrence of this part. So run a loop from reverse direction of part and check if stack of top will contain all the characters that matches to part or not. If stack will contain those characters, then we have to run a loop equals to its length and pop out those characters from stack. So this is basically a simple idea. And so how to approach this or how to achieve this via code? So let us see that. First we declared a stack. So a stack is declared here named stk, and its top is initially pointing to an invalid location. So this invalid location tell us that the stack is empty initially. Let us took this example as our reference, and this n will contain this string length. The string length contains one. So this n for this example contains 10 because this string length is 10, and this plen will contain 2. Okay, so let us run a loop from I equals to 0 till I equals to I less than n. So that means I will start from this index, and first we have to push this inside a stack. So we will push our character a inside this stack, and now our top is points to this because stack is not empty now. So our top pointer is updated and points to this. Again, after doing this, we will check if the stack size is greater than or equals to p of len. That means if this stack size is greater than equals to this part length or not. Why this condition? Because if we have to remove the occurrences of this from our stack, so we will run a loop, or we will pop out characters that is part length nums times. Means if this is 2, so we have to pop out 2 times from this stack. So this condition will safe check, and also we also have to check that whether this stack will contains occurrence of this part or not. How can this be checked? So for now this condition gets false because stack is initially contains only one element, and p length is 2. So this if loop will never executes, and for loop will go to this, and this will push our x into this stack, and the stack size is now 2, and our top pointer will become points to this x. Now this condition is true, and if this condition gets true, only then this will check this function. So what this function is checking, let us see. This will pass our current stack to this part string and the length of this part string. So we are passing our stack not by a reference. So this will create a copy of this stack. That means another stack is created by the name temp that will contain exact 2 elements as the as our stk stack contains, and the 2 elements are a and x. A and x. This is temp, and changes in this temp will not affect our stk because this is not passed by reference. This is a copy of our stk is created, and part will this x and y, and plen is this 2. We will checking from for I equals to plen minus 1. That means this 1 means from this last index of part till this position. If temp dot top, that means this is equals to its last index or not. Now we will find out that this x is not equals to this p of part of I, that means this y. So x is not equals to y, so we have to return false. So if false is returned here, and this true and false is now get false, so we will not pop out our element, and this function gets vanishes. So this stack is also gets deleted, and our I is updated, and our I from this x now will go to this position, and this will push our x into stack. So another x is pushed into this stack, and top will now points to this position. Now this condition gets true. Again, this condition is also checked. Again, a temporary stack is made, and this time temporary stack will contain AXX. This will contain A, X, and X. Again, a loop starts from the last index of part, that means from here, and this will check if this character, that means y, is equals to this x or not. No, this is not equal, so this will return false, and no more lines of this function will get executed, and this function gets vanishes. So again, this check match will receive a false from this function. So this true and false will create a false as answer, and this if statement will not execute it. So I is again incremented. So this temp is now again vanishes, and I is incremented to its next index. So I will now points to this third x, and this will push our s of I into stack. So x is pushed into this stack, and top will points to this position. Now all these previous tops are now erased. Again, stk size means this stack size is now 4, and 4 is obviously greater than equals to 2, so this gets true. But if we check this checkmates function, this will not return as a true, because the last index of part is y, and the in current top of stack is contained x. So this will return a false to this function, and if condition will never gets true, so our I is incremented again, and this time the fourth x, and similarly this x is pushed into this stack, and again this check match function will return as a false. So no need to make the temporary stack, uh, but the compiler will check this. So let us erase the previous pointers, and this time as our I is increases, so this goes to this y, and this y is pushed into this stack. But this time when this check match function is checked, so let us create, after pushing this y, this will check if the current size of stack is greater than equals to p len, that means 2. Yes, the current size is 1 2 3 4 5 6. The current size 6 is obviously greater than equals to this 2, and this check match function is now checked. When check match function is checked, so this will create a temporary stack, that will contains similar characters as this STK contains. So let us create a copy of this and paste it here. So, but this time this is not STK. This is named as TMP. This is temp. Like this, and its topmost pointer is pointing to this Y. Now, when our I will start from this and check if this character, that means Y, is equals to this temporary top, that means this. So we will check if this is not equals to this, and we found out that this is equals to this. So this if will never executes, and we have to pop out our Y from this. So this Y is pop out, and our top will now this, and I is decremented by 1. So I will now points to this X, and again it will check if temp.top is not equals to this part of I, and we found out that this is equals to. So if loop if statement will not executed, and this temp.pop is executed, so this will pop out this X, and the top pointer in now will now points to this X. And while decrementing again this, I will goes to the -1 index, and this for loop will terminated because the condition gets false, and finally we have to return true. So this true and true will now create a true as answer, and this if loop gets executed. So when these both conditions are true, we have to pop out our number of characters equals to p of len. That means if these both condition gets true, we will actually having a substring of part at the top of our stack. So we have to pop out that substring from our SDK. So we will pop out number of time plen number of times from our stack. Plen is now 2, so we have to pop out 2 characters from our stack. So let us pop out them. This Y will get popped out, and this X will get popped out. And our new top is this. Again, I is incremented, and this Y, this will points to this Y. So we have to push this Y inside our stack, and new top is this. Again, we have to check that if stack dot size is greater than equals to plen, yes, this stack dot size is greater than equals to plen. And also we have to check if this stack will contains this part plen part or not as a substring. If it contains this plen, that means both of the characters or the characters of this plen is obviously at the top of the stack, and we actually check this condition in this check match. So this check match function gets executed, and again a temporary stack is created for us. Let us paste this. So this is a temporary stack that is created for us, and again a loop will start from this index, and this will check if topmost characters of this temporary stack is equals to this or not. Yes, y is equals to y, so we have to pop out from this. So this y is popped out. Again I is decremented, so this will points to this x, and again uh, this x is equals to this, so we also have to pop out this x as well. And when again I is decremented, so that will points to an invalid location, and we have to return true for this. So we have to return true, we received true, and when we receive true and true, so we have to pop out our from our stk as two numbers or two characters from that. So we will pop out our this y and this x, and this temporary stack is now gets vanishes as this function gets vanishes. So let us erase this, and let us erase this as well. Now again I is incremented, and I will points to this y, and here we can see that this will contain as x and y as the substring, so we will not making this time temp. And clearly we now observe that creating a temp, and then we will checking that if that current character is not equals to the top of the stack or not. So we will finally return true, because this temporary character of the copy of this stk will contains both of the characters of this part, so this will return true. So now remove this and increment our y I. So this will now push our y into this, and again we find out that we have a substring as a part, so we will have to delete this. And as our I is incremented, the last character is this b, and for this condition gets true, but this will return a false, because when we created a temp stack, then that stop is obviously this b, and this x is not equals to this b, so this will return a false to us from here, and this for loop will never execute it. And again we have to increment our I, then I will points to an invalid location, and this for loop will now gets completed. So these statements are now executed. We will create an empty string first, and this empty string will be like this is an empty string first, and we will run a loop while stack is empty, while stack gets not empty. uh, Stack is not empty right now, so we will make stack top, that is b, this b concatenate with our current res, that means an empty string, and this will create result as b, and assign that to our result string. So our resultant string is now this b, and pop out our topmost element from the stack, so this b gets popped out. And again we will check while if that stack is empty or not. No, the stack is still not empty, so this will make our stack plus top. That means, what is stack plus top? It is a concatenate with our current res, that this makes our answer as AB, and this makes our answer as AB and assign that to our resultant string, and our resultant string is AB now, and we have to pop out our current topmost character from the stack. So we will pop out this A from our stack, and again when we check that while stack is empty or not, we find out that stack is now empty, and we will now return this AB as our final answer to the caller. So this is basically a very basic stack implementation, and in this we can achieve a time complexity of big O of n, that means the string length, and multiply to this part length string, that means big O of n into m. So let us code this now. First we have to make a stack of characters, store our length, then run a loop from I equals to 0 till I is less than n, push our current character into this stack, and check if stack.size is greater than equals to this plen, and this stack will contain this part or not. We do not have to pass our plen into this function because we are passing the string itself, so we can calculate the plen into this helper function as well using this. But if we were using, suppose we were using the C or any language that does not provide any built-in function, so that is why we were passing plen. But most of the languages now will provide a built-in function to check length of a string, and if both of these condition gets true, so we have to pop out the number of p characters that equals to plen. So let us pop out our characters from this. Finally, let us make an empty string first and traverse on stack until it's get empty, and assign our rest to top plus concatenation of the current rest, and finally we have to return our resultant string. Stack of characters, that means let us name that as temp. This is run a loop from plen -1 and check if temp.top is not equals to this part of I. If it is not equals to this, then return false from here, and no need to check any further condition. And if it is equals to this, pop out the current topmost element from the stack, and finally we have to return true. So let us check if it is running fine or not. Let us submit this. So this will concluded our today's daily lead code challenge, and our completion streak is now 305 days. So thank you so much guys for seeing this, and if you do like and do understand something from this video, please like and subscribe to our channel and follow us for more daily lead code challenges. Thank you guys.